Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop, and we're working on an LBSC TICH locomotive. It's a little 3.5 inch gauge locomotive. This week's episode, I'm making fittings for the water pump, and I talk a little bit about testing it, making sure there's enough space for the bearings, and I made a little special washer. So I'll show you some of that stuff. Here are the fittings for the top side water supply. According to the book, this outlet goes to one of the tanks. I believe the right-hand tank is a saddle tank engine, or it's a tank engine. The rearward outlet goes to the bypass valve. So that's actually an 1/8 inch pipe according to the drawings. So we'll get into that throughout this episode. A lot of little segments in here. Here's the underside of the locomotive and the underside of the pump. Let me see if I can tighten up the camera just a wee bit. There you go. Okay. So here's the underside of the pump and the fitting that I made for it, and the little nut that will hold the pipe in place whenever I get the copper and make the unions. But I'll talk more about that as we go along. And I hope you enjoy this episode. Should be probably 20-25 minutes, I guess. I tried to shoot a lot of little segments for you and make it interesting. So hope you have a happy new year, everybody. Thanks for joining us along. And a couple of interesting things, live stream things that I've seen on the web. If you don't know, there is a very talented machinist. Her channel is called Blondie Hacks, and she's building a Kozo A3 locomotive, 3.5 inch gauge locomotive, and she's starting with the boiler, and she just published a segment recently on making the formers and actually annealing the copper plate and forming that into the pieces that she's going to need. So check that out. It's interesting, and I'm very excited to see other folks that publish the 3.5 inch gauge locomotive stuff. It's kind of cool. As you can see, it's a very practical size. So again, hope you enjoy this. Have a happy new year. Thanks, everybody. Before I put the entire pump back together and start working on the cylinders, I wanted to check over and at least take some notes. I'm not going to make the fittings right now because I don't think I need to. But I took the pump apart, and the first thing I noticed, and I'm glad that I checked it, this one does have the little extra tip on there, which is supposed to help prevent airlocks in operation. LBSC talks about that in the book, so I'm glad to see that that's on there. The ram is a little bit smaller. It's supposed to be a 5/16 inch piece of stainless steel. This one is just a 1/4 inch, but since it's already made, I'm just going to go with it for now. Here is the little arm that it acts as a locking pin for the drive arm, and there's the little nut. I think it's a 256 nut that and the little arm is longer so it can drive the rod that goes to the lubricator. And over here, let me show you these pieces. Here is the top fitting. As you can see, this one is just smooth. It's just a piece of hex brass that's drilled through or reamed through smooth, 3/16 of an inch. So I'm going to have to make fittings that will go on here, and I can do that later, silver solder them into those holes. That's no big deal. I actually like stuff like that. You can see the bottom design of it. It has it's kind of a castellated design, and that's to promote the water flow for the ball. The ball needs to move a little bit, but the castellated design helps. And there's the 5/32 inch ball bearing. It didn't come with any, but I have a large selection of them, thank goodness, from previous projects. And this is the gland nut, which keeps the packing in place. That was already made. I knew I was going to do that. And here is the this is the bottom fitting. It just has one space machined in it, and that'll be for the water supply that comes from the tank. So before I put all this together, I'm going to put the ball bearings in place and check to make sure the spacing is correct for the upper and the lower fittings, and then if that's all good, I'll put that back together. Just loosely put it back together. I'll come back to it when I make the fittings and the rest, but that's kind of just wanted to point that out because it's something smart to do when you inherit a partially completed project. You want to check dimensions and compare it to the drawings. Okay, one more thing I'm doing with the brake system. I've replaced the Phillips head 440 screws in here on both sides with a little brass straight bladed one. I think it looks a little bit better and a little bit more vintage look. The other thing I did, I took my Dremel with a grinding stone and I relieved the inside just a little bit so I get a good fit on the wheel. So I wanted to kind of make those little fine-tuning adjustments before I adjust the tightness on the rods. Okay, I got the new screws put in here. I think they look pretty good. I think the fit is good too. And also I reinstalled the ram for the axle pump and it's rotating really smoothly now. There's still a little teeny bit of a sticking point. You can kind of feel it easier than you can see it. But, you know, with the side rods and so forth, just a teeny bit. It's not bad at all. So I'm going to set this up. I'll put the camera in the little holder here, my little inexpensive holder, and so you can watch me go back and forth, and it only takes about a half a turn on the brakes to lock it down good. So let me show you how that works. Okay, hopefully you can see this okay. So the brakes are off completely. I'm going to put it on till there's just a half a turn there, and it wanted to lock it up. So this is slack. Here's the brake stand. Put the half turn in now, and let's see. There we go. It wants to stop. So I think the brakes are in good shape there. Pretty happy with how that is, and the fact that the axle pump is back in and it's not causing any difficulties. Let's try the brakes again. Okay. So half a turn. Yep, about one turn, I guess, is what it takes to really get them applied. That's not bad at all. Less than a turn. Very cool. Alright, very happy with that. And we'll be thinking about the fittings for the axle pump, and we'll start to think about the connections for the cylinders and connecting the valves up. That's going to be exciting. Okay, Happy New Year, everybody. Here we have all the cylinder parts laid out for the next big phase that we'll need to get done to have this thing running on air. Decided, even though I think I made a comment that I was going to wait, I decided since I was messing with the pump, this would be a good time to get it done. Plus, I'm starting a new job and I don't know how much spare time I'm going to have. So, again, one more little thing to be taken care of. And so I'll be working on the pump. I did a couple of things, though. As the book talks about, I put a ball in there, a little 5/32 inch ball bearing inside each side, and then I used a depth measurement tool, and I measured the depth on the bottom one was fine. There's the ball bearing stuck inside there. The top one, there's not enough space between the bottom of the fitting and the ball. It needs a little bit more free space. So what I've just been doing is playing around with some copper washers that I had. Unfortunately, these are way too big, but they give me a good idea of the thickness that I'm going to need. So the first thing I'm going to do is make up a custom washer that gives a little bit more space for the ball bearing to flow. Then the next thing I'm going to do is make up some water lines to go, or at least the fittings that will go on there, and I'll bring you along for that process. Now, regarding the fittings, I've always made my own fittings, and I've used a design that my mentor Fred had shared with me on my large locomotive, my Allen Mogul, and they've worked fine, and I've been happy with them. The one thing about them, though, that you'll notice that the nuts are rather large, which on a locomotive this big is not that huge a deal at all. But LBSC points out that with a small locomotive, if you can make them smaller, that they'll look a little bit better. So having said that, I studied his notes about, he calls it mass production. He's talking about the nuts here on page 127 of the book. And I also researched a little bit. This is another resource for you. If you look at the IBLS, the International Brotherhood of Live Steamers website, Bill Van Broecklyn wrote an article, a very brief article, and provided some sketches and a table of smaller size nuts for in cones for better scale fittings, I guess is the best way to say. The key difference between his and many others are that the little cones themselves, there's no additional material on the cone. The cone is just a cone itself, which is carefully made and made out of copper and then silver soldered to the end of the tube. And because there's no backing, no sleeve, if you will, behind the cone, the nut size can be a little bit smaller, or in this case, a lot smaller. The rest, the other part of the fitting, the design is pretty standard, pretty typical. So what I've done is I ordered some material. I had some 5/16 inch brass left here, and I ordered from one of my favorite suppliers on eBay, a guy named Stoner's Tools and Raw Materials. And this is a little 2 pieces of 5/16 inch hex brass, 8 inches long, which was about $12 delivered, free shipping. So that'll be enough for plenty of nuts, and I'm going to try to make some fittings today. I also ordered some copper pieces to make the cones out of, but that hasn't arrived yet. So we'll make the fittings. As you can see, I need to make fittings anyway for the top and the bottom of this thing. So we'll make the spacer and make some fittings and make some nuts, and then when the copper gets here, we'll make the cones. Okay, not a lot to see here, but I used a piece of 7/16 inch round brass and drilled a hole just a little bit oversized of a 1/4 inch, and then I cut it off at about 90 thousandths thickness. Ended up with a little coning to it, and I had to file it flat. But I got it just to the point where, if you can see the hole there, one of the holes is the top 2 holes, they'll be facing fore and aft like they're supposed to. So that's exactly what I was shooting for. So now when I make and silver solder the fittings on, they'll be in exactly the right place. First stage of making the fittings to silver solder into the pump body. Decided to start with some 5/16 inch brass, and I turned it down to 1/4 inch so I can thread this 1/4 by 40. Before I do that, I'll go ahead and drill and countersink it. Drill it through long enough to cut off. I'm just going to make 3 of these today. There, I just wanted to show using the countersink to make the hole for the cone will go into. It's really, especially with these small ones, it's kind of hard to see, but I was using one of my Sunday go-to-meeting countersinks here. It's a 1/4 inch body, so it's going to give the right size, and I keep this is super sharp and just right, I think. I'll look at that with a, it's hard to get even the focus on there. But you want to be careful that you want to make it deep enough and big enough, obviously, so that there's a seating surface for the cone. You also don't want to make it so deep that that you end up with a knife edge here. So what I'm going to do now, next I'll touch this with a file, and then I'll thread this portion here. Okay, here's the 1/4 by 40, as Keith Appleton says. Use the tailstock die holder to thread the brass, and I think it came out really nice. It seemed to have cut pretty smoothly, and there we go. So you can see the, Sorry about the erratic camera work. I'm just trying to find a good angle for you. There we go. So I'll smooth that out with a file, and I think we're in good shape. Here, before I do the actual cutoff, what I wanted to show is I'm removing as much material as I can, because once I cut this off, I have to put the 1/4 inch portion in a 1/4 inch 5C collet chuck, just to trim that down, the little stem down to 3/16 OD. So I'm getting it really, really close, just so I can, while there's some strength to the material here, I can remove the most of it. Here we are with the fitting cut off. As you can see, I got a little piece of rod there. I got tired of chasing pieces out all over the workshop underneath the lathe, so I keep this piece of wire rod handy, just to grab small pieces like this. So now we can flip it around and finish off the back side, and this piece will be done. Alright, here's a little stub turned down to 3/16 of an inch, just slightly under, and it's a nice kind of snug fit actually on the fitting. So that'll be perfect for silver soldering on. Now I just need to make 2 more. Getting ready to silver solder the little ends into the fittings. Here's the one for the bottom side. I don't know if I showed that one yet, but you can get a pretty good view of the fitting. This part where my thumb is rubbing along the threaded portion, that's only a 1/4 inch long. It's 5/16 inch brass stock that I used, and as you can see, there's a little, it just fits right in, the little 3/16 inch stem that fits into the hole there. So that'll be perfect for these purposes. Also, the nuts came out pretty well. I'll show them in the next segment. I'm actually going to make a separate one. The thing for the top portion, and you can see where I've got this marked, that the little scratch there, that's for the front, and that's going to be the outlet to one of the tanks, and that's supposed to be 5/32 tube. The rear one is supposed to be for a 1/4 inch tube, and the nut basically is the same size except for the through hole should be a little bit smaller. So I'm going to remake the one for that one to accommodate the 1/8 inch tube. Not sure why LBSC called for an 1/8 inch return tube to the bypass valve, but that's what he calls for in the plan, so I'm going to go ahead and make it that way. Okay, and moments later, here's the completed ones. I just dunked them in water to cool them off, and now I'll put them in pickle. And I like to use the more environmentally easy things. I just use 100% lime juice or lemon juice. So there's the one. Here's the second one. They look pretty ugly when they first get done, but it looks like I got pretty good coverage there. And I tried, after I dunk them, I beat on them a little bit, try to make sure that the joint is solid. There's nothing ready to come loose here. So anyway, it'll look a lot better after I pickle it and buff it up a little bit. So I'm going to let these sit in the lime juice and boil off some of the, not boil off, but clear off some of the scale there for a few minutes, and I'm going to make an extra nut for the 1/8 inch return. Pardon me talking over the lathe, but I'm making a couple of nuts here. I just wanted to show I'm going to be making them LBSC style. What I'm using here is the 5/16 inch hex. 5/16 inch brass hex stock, and this is a number 30 drill, so it's a very small hole that's going in the back. These will be for using the 1/4 40 fitting size, but 1/8 inch pipe, which is going to be needed for the return line from or out of the axle pump and into the bypass pump. So decided to go ahead and make 2 nuts while I'm at it. And the LBSC style, his mass production method, basically is to part off a whole bunch of blanks. What I thought I wanted to do is go ahead and, while I've got it in the lathe, I could at least drill the through hole here, the number 30 hole. Then I'll cut them off and I'll flip them around separately and do the drilling and tapping. I'll show you those in just a second. Here we are parting off the first one at a 1/4 inch thick. I did use the file to kind of relieve the corners here. And as you can see, I have my little wire rod to catch the nut when it comes off. Okay, I've got the little nut blank, the first one with the little number 30 hole through it for the 1/8 inch pipe, set in the 5C collet chuck there. And the beautiful thing about that is it's, very well centered. You can also see I've got the number 2 drill, that's the tapping size drill for the 1/4 inch 40, and I've got tape wrapped around it so I can help keep track of my depth of drilling, which is 3/16 of an inch. Drilling's complete. Let me back the drill off and I can give you a little close-up. Sorry about my finger being in the way. So you can see it's a nice thing all set for tapping. I'm tapping by hand using the 1/4 inch 40 tap. It's the bottoming tap, and just rotating it by hand with my little tailstock holder here. It's easy to get all the way in. Once I feel all the resistance from being at the end of the hole there, which is about here, back it up, and I can use the lathe power feed if I want to put it in reverse all the way, but it's a very short section. Basically what I've been doing is do the first tap like that, and I'll clean my tap off. I got tap paste and such on here. Clean it off, get any chips out, and I'll run it one more time to make sure I got a nice tap hole. Here's the silver soldered fixtures, fittings rather, right outside of the pickle. I dunked them in water again, scrubbed them off with a little wire brush, and shot them with WD-40. That's all I've done to them, and that's how nicely they clean up. So here's the one for the bottom side. And I used one of those WD-40 cans with the spout on it and the straw on the end, and shot it through so I know there's nothing blocking the passages. Pretty happy with how these have come out. And here's the fittings for the 1/8 inch pipe. Got a piece of 1/8 inch brass pipe here, and it shows you that the number 30 drill is plenty loose, but also not a lot of excess slop there. So I'll put these in position. Real happy with how they came out. Just wish I had the copper so I could go ahead and make the cones and solder it on there and see how it actually fits. I'll go ahead and wrap up this week's episode with this shot of the TICH chassis up on some rails. It's looking good, really coming together. I'm getting anxious to get working on the cylinders, and I'll be bringing you updated installments as I can. As I mentioned in one of the little segments, I am starting a new job tomorrow, and I anticipate I'll be very, very busy. It's a job I'm very excited about. I'm very much looking forward to it. So that could impact some of my workshop time and my videos that I post, but I'll try to put together meaningful segments for you, and thank you for your participation. Thank you for the thumbs ups and the kind comments, and I'd like to wish everybody a Happy New Year. Thank you.